Hello, in this tutorial I will teach you how to do the shattering in a completely controlled way. We'll control the shattering propagation by the texture, and the shattering speed will be independent on the number of faces, or more importantly on the simulation steps. I will show you how to create and use particle custom channels and use particle color as material based color. Once the particles are cached, I'll show you how to replace or scale cached particles and so much more. So first I'm going to create NodeWorks somewhere in the scene, and we're going to add this guy into the NodeWorks as a particle shape. So open up the editor and we're going to create import shape node, and from the import shape node I'm going to pick the guy and it's going to become a particle with the shape on it. It's always a good idea to give particle groups some meaningful names, so this group 1 will become the guy particle group. For the fragmentation I'm going to use the face shatter node, and this node requires get particle group to be connected to, as it requires particle and its shape on each frame. So in each frame it gets the input shape, do the fragmentation on the face level, and output fragments in a new particle group that we're going to call the burn, and change the color in the viewport, and that particle are going to be used as a fire source as well as for the propagation. By default it fragments all the faces throughout the shape. So what we need here is to enable the remove at source. So as the face is removed from the shape, it leaves an empty area. It can work on the polygons mode, but it can also work on the face level. Now for this tutorial I'm going to leave it at the polygon mode, and we're going to convert only one quad here. So we need now to add the activation by position, as we don't want to activate all the faces at once. So we're going to use this activator sphere here, and we need to grab its position. So it's going to use the object info, and we select this activator, and we need to use the position of this activator node and plug into the custom position for the face shatter. As you can see, nothing happens yet, so we need to increase the activation distance. If we increase this distance, it's gonna activate anything that's inside the distance from the center of this object. So we're going to use this something like 3, and we just need one particle. Now I'm going to create another tab. It's going to go burn, and here I'm going to get our burn particles, and we're going to convert them into another particle that we're going to call ash. Ash particles will also be used to activate the shatter regions. So I'm going to set particle group, and we're going to ash. Now within the face shatter we're going to enable the activate by particle and select ash group, and we need to increase the distance. Alright, so now we have propagation. Let's see just those last faces to be activated. Now as you can see, this activation is very uniform, and we basically don't have much of the control for the activation. We could of course add some counter here, check simulation frames, and trigger transition to the particle group based on every 10th frame, something like that, but we're going to use another method. So we're going to create custom channel. I'm going to pin this, right click, add channel, and we're going to create channel as we're going to call the counter, and we're going to use this counter. So for example, when they burn here, I'm going to call the set particle attributes, and for this counter I'm going to set a constant value of 1. So when the phase shatter, those red particles are going to have the counter value 1. And now here, for this burn, I'm going to create another burn node, and I'm going to create a math node, and we're going to use subtract. We need float inputs and outputs, and now I'm going to get our counter here, which is a float custom channel, and I'm going to subtract like 0.2 on each frame, and we're going to put this to set particle attributes, not on speed, but you keep the Alt key down, click and drag back to the counter. So now we get the counter, we decrease it by 0.2 and put back to counter. And now here we're going to check the counter, and we're going to compare it. If it's less, or let's say less or equal to 0, in that case is going to convert particle to the ash. We don't need those two connections, so visually we can just remove this one. And now, as you can see, as the counter progresses, we have now control over the propagation. You can increase this constant value here, for example for 2 to 2, and it will decrease the propagation. So this is the counter. You can set it to any value that you need. Now the problem with this setup is, if we go to the simulation and say 5 simulation steps, the propagation is going to be 5 times as fast. Why? That's because on each simulation sub-step we reduce the counter by 0.2, and it's done a lot faster. So we need here something to do with the simulation step. So create a node simulation info, and it has the GT. This is the frame fragment. For the sub-steps, it's, if you have 2 sub-steps, it's going to be 0.5, it's going to be 0.25 for 5 sub-steps, and so on. So we're going to use a math node, and we're going to multiply the sub-step with the, we have here 0.2, so we're going to have the 0.2 value here, and we're going to plug this into the B value. This is a bit crowded now, it's as the display is not so big, but on the real monitor you can stretch all these nodes as you wish. So now we have a system that doesn't depend on the simulation sub-steps, so that's really great. So this simulation is nice, but it's kind of boring as the propagation is very uniform, and we're going to change that. So for start, on the NodeWorks I have prepared some materials here that we can use. So let's apply this noise map. As you can see, the object has the blue and orange color that we use later, and we have the same material here with an identical map that has light and the dark area. So light areas will be at the places of the blue color and the dark area on the orange, and we'll use those colors as a counter. So white area will have the higher counter value and dark area lower counter value, which means propagation will be faster where the lower counter value is set. So it will propagate slower on the blue area and faster on this orange one. So we go back to the node, and from this phase shatter here we can remove all this, and we need to do some object test node, and we're going to test against the guy object, and this the guy, we need particle from the surface. So this node will find the closest point on the surface, and we're going to use this to evaluate a text map. So we're going to use this text map intensity for the counter. So it's going to go into the counter for the text map 1, and we just need to pick the text map, and it's going to be in the sample slots here as burn map. And now we have set up, so we have burn based on the color. As you can see, it goes slower in the blue areas, and when it reaches the orange one, it goes really fast. So you can use any map to control the propagation. Now I'm going to add some FumeFX wind. That's going to move our particles around, maybe a little bit up and towards to the camera. I'm going to set this to visualize wind, and we want a lot of turbulence, so that, let's see the view, maybe a little bit higher scale. Let's scale to 30, and we're going to use this into the NodeWorks for our burn particles. We add another tab here for the ash particles. I'm going to grab this ash particle and then FumeFX forces and pick this wind here. So now I have this wind going through the particles and moving them, and we're just going to add some little bit drag, and let's see how the force and motion looks from the above. Maybe a little bit less. Okay, so let's bring up the NodeWorks here. We can add some spin, and now we're going to let it spin in both directions and use some spin axis variation. We can add spin rate variation, so it's adding all the variations here. Also, what we can do here is to use the math operator, and we can reduce the scale. those particles a little bit so they get smaller and smaller, and we're going to use this to set particle attribute and hold Alt key and move this to scale. Now you'll see that our particles are scaling down as they age. Now if we open up the Arnold render view here, we'll get those particles are going in with the same color as they picked from the surface. However, if we want those particles color to fade over time, we can use that easily by using Arnold User Data. So for that, I'm going to the Arnold User Data export, enable color, and it's going to be exported as the FXP color in the node network. And I'm going to use the first thing, going to use this text map. We're going to evaluate the surface color map, and that's going to be the map 2, and going to plug this as a particle color. So now here for the ashes, I can get this color. Again, use the math operator, and we can set the second pin to float, so you don't have to scale all the three components. Scale, for example, 0.9, and of course we're going to multiply color by 0.9 each frame and set this color back to particle. So now we're changing the scale and the color with H. Now we can check if everything is working properly if we display here particle color. So initially see the particles pick the color from the surface, and later on they start to get really dark. So as it burns, it converts to ashes. Now put back to the group, display mesh. Now how to pass this information to Arnold? That's fairly easy, and we're going to assign now I have prepared here the NodeWorks multi-material to the NodeWorks, and if you can see, I have the ash material prepared here. So there's the material submaterial ID 2, and I will want to assign the same material ID on the phase shader, the shattered particle that would be on the fragment top material ID, set it to 2. This ash is now, as you can see, completely white material, and if we click here on the button for the map, click user data, and we need the RGB, and here is going to be FXP color. So we're going use directly the user data for the base color. And now if we go up and hit the Arnold render view, we see that the color is fading to black. Now we're going to add a last component here as about particles. It's called the sparks node, and we're going to generate sparks from the burnt particles. Those are the red particles that are generated immediately from the phase shatter node, and we're going to use the spawn generator, and it's going to be the sparks particles. Let's set it to green, and as you can see, we are already creating some particles, but of course we're going to generate particles only when this particle is generated. And if we're going to increase the number of faces of the model, there are going to be too many sparks, so we can add some filtering. So going to use a random node, and it's going to generate random number from between 0 and 100, and we simply compare this number and ask if it's less than 10, which means only 10% of the burned particles are going to be spawn spark particles. Now we can remove this connection. So you can see we generate only 10% of the spark particles, and now we're going to add also some FumeFX force and drag. FumeFX force, I'm going to pick. Now you can see that those spark particles doesn't follow the fractured particles. That's because of they have initial velocity set. We don't want this. However, we want those sparks to be very small, and I will decrease their size to 0.4. Decreasing the size means that the particle mass will become lower, and lower mass means bigger acceleration using the FumeFX wind force. So smaller mass means faster acceleration, and higher mass means slower acceleration. However, you can avoid that. If you want constant acceleration, whatever the size is, just use the mass node and set mass for the particle to 1. Now whatever size you put here or density, acceleration is going to be identical, so you don't have to worry about that. So those are the sparks. And now, for example, if you want to get some more detail, we can easily do so. So go to frame 0 and show you the wire view, and for the guy, when you import it, we can apply some tessellation to the shape. Easy as that. You can increase as much as you wish. So now we have refined the number of faces, and we generate more particles. You can of course increase number of sparks. If, for example, we can use 20% of particles as sparks. I'm going to add to those sparks simple shape. I'll use the tetrahedron and using the material ID 3. So now we have all kind of shapes here, so we can preview in the Arnold. We got the sparks, we got the faces fractured, and now we're going to add some FumeFX. I have FumeFX already set up here, so I'm going just to go through the parameters, but here you can create FumeFX from the toolbar, adjust the grid spacing, all the sizes, change the output path, and you can simulate smoke and fire. So here just make sure that this grid encompasses particles, and it's going to go into the wind, is going to blow the smoke just pretty much as these particles are going here. So one great thing about FumeFX is that we have the parameter check, and it lets us compare current parameters to what's been set up as the default. So generally you want to change your output path. We're going to export fuel, smoke, temperature, and velocity. We might need temperature for the black body rendering and velocity for the motion blur. Now under the simulation tab here you can see that fuel has been changed from the default. Ignition temperature has been reduced, so whatever there is fuel in the grid we want it to burn. Expansion is increased a bit, so when it burns it creates additional pressure in the grid. The fire creates smoke is enabled, so when fire burns it's going to create additional smoke. For the smoke, dissipation mean density means that all the smoke that's below dissipation mean density value is going to be dissipated at this strength, but we set this to 0, so we don't want any dissipation to occur. Also for the rendering, render step size was set to 100, as we want this to render a bit faster. Now we'll go back to our NodeWorks, and I'm going to go to the caching tab and go to the path, and I'm going to hit export. I'm going to export just about everything, it doesn't matter in this case. And you can see if you change to the cache mode here, all the particles and everything is cached, so we don't have to recompute this over and over. So I'm going to add a new workspace, and I'm going to switch to the workspace, and we're going to do some FumeFX here. Each workspace has its own settings, so first I'm going to enable Arnold User Data for FXP color export. So I'm going to create the load particle cache node, and I'm going to select our cache files, and you can see them in the viewport. Also I'm going to check create missing groups and missing channels, so it automatically creates the channels and groups from the cache. Now one thing to say here about the load cache is that now we can, for example, load a burn group, and we can change the shape, for example. So with the burn we can change to the pyramid, say, and we can get the ash group and change to simple shape, and a side, for example, cube. Now we can do whatever we want with caches, as we have all the groups inside those caches, so we can access them without any issue. Now remember that this load particle cache is in the load replace mode, which means that each frame is going to load particles, replace everything in the scene, so those nodes will be applied each frame. Okay, so we don't need this was just an example. And now we're going to add those particles to the FumeFX simulation. FumeFX simulation reference is the node that provides interface for other FumeFX nodes, and we're going to create it first, and then we can generate grid sources node. And now we need to generate two types of nodes. One will be from the get group from the burn node, that we're going to connect as a grid source, and this grid source I'm going to set it to emit from the geometry shell, enable fire, temperature, and another group going to be the guy, and this guy is going to be grid obstacle, which means this shape is going to use as a shell, and the smoke and fire are going to collide with the remaining guy shape. Okay, now from the FumeFX I need to add the wind node that we initially used for the particles, so that everything is going to follow the wind. Now I'll hit the simulation now and get back once it's done. The simulation has finished. Now I'm going to open Material Editor and assign Arnold standard volume to FumeFX. And from the FumeFX I need to set the shader to Arnold and Redshift. You can directly render with Arnold or Redshift renderers, and I'm going to export smoke, fire fuel, temperature, velocity is going to be used for the motion blur, and later I'm going to use color, so I'm going to export all the channels to the shader. Now I'm going to start the Arnold render view. I'm going to lock it for the physical camera and enable the render view. So you see there's some initial rendering settings, work pretty nice. You can reduce the smoke density and probably black body temperature reduce a little bit, so we get a bit warmer color, and emission is okay. So that's what you got for the initial setup. Now if you'd like to emit color from the render view, we can do that as well. So I'm going to open the NodeWorks editor and I'm going to access color and use as a grid source, but for the color I need to enable connect color into the color pin, and also within the FumeFX we have to set up the simulation with color, and we're going to do that by enabling the color to simulate. In the rendering it's enabled, and for this standard volume scattering channel will be color. So everything is set up for the emission with the color, and now I can click simulate again, and now simulation will be done with the color that is going to be picked up from the particle and emitted directly into the FumeFX as a color that will be used for the smoke scattering color. And now you can see that the smoke color also goes from the blue to the orange. Thank you for watching, and please subscribe for new tutorials.